I'm Anil Kumar. Welcome to my series on quadratic functions. Now, I'm going to discuss with you some of the most important questions based on this unit. I've picked 8 questions from one test paper, which are absolutely excellent questions. I would like you to copy these questions, answer them, and then look into my suggestions. Question number 1 is to find inverse of the function, state restrictions to ensure that the inverse is a function, and also to determine domain of the function f of x when range is y less than equal to 2. Question number 2, we are given a function. You need to find the value of k so that the function has only one zero. Question number 3, we are given x-intercepts and the y-intercept. You need to find the quadratic equation. Question number 4, a quadratic and a linear equation is given to you. You need to find points of intersection. Perfect. Now let me move this page slightly up. You can now copy the rest. Question number 5, you find the value of k to make the function a perfect square. Question number 6 is an application question, a word problem, which is based on profit and loss. I'd like you to pause, copy the question, answer, and then look into my suggestions. Question number 7 and 8, both are communication-based questions. We'll analyze the roots of the function from the given equation in these questions. So I hope these questions are clear to you. Take your time to copy them and then solve. And now, one by one, we'll take solution of all these questions. The video might take about 45 minutes. Let's begin. Question number 1. Find inverse of f of x, which is equal to minus 4 x plus 1 whole square plus 6. State restrictions on f of x to ensure inverse to be a function. And part C is determine domain of f of x when range is y less than equal to 2. Very important question. Now let's see how to find inverse. So I'm rewriting the question in the form y equals to minus 4 x plus 1 whole square plus 6. To find the inverse, what should we do? We need to interchange, right? So we'll find inverse now. So we'll swap x and y and then solve for y. So we could write this as x equals to minus 4 y plus 1 whole square plus 6. And now we'll take 6 to the left side. We get minus 4 y plus 1 whole square. Dividing by minus 4, we get x minus 6 divided by minus 4 equals to y plus 1 whole square. Now square root both sides. So we get x minus 6 divided by minus 4 with plus and minus sign, y plus 1. And now we can isolate y, bringing 1 to the left side. So we get minus 1 plus minus square root of x minus 6 over minus 4 is equal to y. So that gives you the inverse of the function. Let me rewrite right here inverse. Now you can see that inverse is not a function because of this plus minus. So we are writing this as plus minus square root of x minus 6 divided by minus 4. Now minus 4 is also within the square root. Okay. You could write this as half outside and things like that. Minus 1. You could write like this also. Taking this as outside half, right? Square root of this minus will make 6 minus x in the numerator. Perfect. Minus 1. So that is alternate way of writing. So that becomes the inverse. Clearly, inverse is not a function, correct? Since you get two values for x values. So I'm writing only f inverse, not writing x here. It's very important to understand. Part B is state restrictions of the function to ensure inverse to be a function. So let's get back to the equation given to us, which is f of x equal to minus 4x plus 1 whole square. So that means a parabola is opening downwards, right? With the vertex at minus 1, 6. Now to restrict the domain, what can we do? We could say we could take one side of this parabola, correct? Since this axis is at x equals to minus 1, restriction could be what? So we could restrict like take x as greater than equal to minus 1. Since this axis is x equals to minus 1, it could be either side. So we could restrict like this. In that case, we'll get our inverse, a function. And if we restrict one side of it, and which is greater than, that means the right side, then the inverse will have positive here, right? So we'll get positive. Let me take the second equation. Half of square root 6 minus x minus 1. Correct? And since this parabola opens downward, the inverse will open towards which side? Open left side. Is it okay? So that is how it is going to be. So in this case, for the inverse, x is going to be less than equal to 6. Right? So for 6 it is okay. So it is going to be less than equal to 6. The inverse of this function. Okay, so that is very important to understand. And the y value, if I restrict the domain, then it is greater than equal to minus 1. So y is greater than equal to minus 1 for restricted domain. Okay. Well, that is not the part of the question. Part of the question is only up to this point. So that we have answered. Now let's look into the third condition, which is very critical. Determine domain of f of x, this function, when the range is less than equal to 2. What does that mean? Now that really means that this function vertex maximum is at 6. We want to restrict where the range is below 2. So basically we need to find what are these x values. And therefore, the range is either side of these values where the function is 2. You get the idea. So we have to find a point where minus 4 times x plus 1 whole square plus 6 is equal to 2. Then on either side of it will be our range. Because within this interval, range is greater than 2. If we take this line as y equals to 2. Right? So we'll equate it to 2 and then solve for x. So taking 6 on the other side, we get minus 4, x plus 1 whole square equals to 2 minus 6, which is minus 4. And these two minus 4s can cancel. You could write like this also. Equals to minus 4 divided by minus 4, which is 1. So we could have x plus 1 whole square equals to plus minus square root of 1, which is plus minus 1. Right? So since we did square root, I'm removing the square from the left side. And now we get the value of x as equal to minus 1 plus minus 1. Right? So we get two values, one of them being minus 2, the other one being 0. So that means the points where y equals to 2 are at x equals to minus 2 and 0. Perfect? So now you can write the domain of the function. So the domain of the function will be on either side, including zeros for this particular equation. So the domain will be x is less than equal to minus 2 or x is greater than equal to 0. Do you see that? So for that, y value is going to be less than equal to 2. So that is how you're going to answer this question. So that is your part C. So I hope these steps are absolutely clear. Now let's move on and take the second question. Question number 2 is, if f of x equals to 3x squared plus k minus 1x plus 12, has 1 0, find k. Now for any quadratic equation to have only 1 0, b square minus 4ac should be equal to 0, right? So in our case, what is the value of b? b is equal to k minus 1. It is coefficient of x. As far as a is concerned, a is coefficient of x square, which is 3, and c is equal to 12. So we'll substitute these values here. b square means k minus 1 whole square minus 4 times a is 3 and c is 12. That should be equal to 0, right? So let's take these terms to the right side. So we get k minus 1 whole square equals to 4 times 3 is 12. So it is basically 12 times 12. Purposely, I'm not writing 144, writing it as 12 times 12 since we have a square on this side. So let's do square root. So we get k minus 1 equal to square root of 12 times 12. So whenever you do square root, you write plus and minus. Obviously, this is 12, right? So which gives you plus minus 12. And the value of k is plus minus 12 plus 1. So we get two values for k when the equation will have just 1 0. So one of the values is k equals to 12 plus 1, which is 13. And the other one is that k equals to minus 12 plus 1, which is minus 11. So we have answered that k is equals to 13 or minus 11, right? So that is how we are going to answer this question. I hope it is absolutely clear. Now let's take question number 3, where we are given the x-intercepts. We need to find the equation of the question number 3. This is one of my favorite questions. The question here is to determine equation of parabola with x-intercepts as minus 3 plus minus square root 5 with y-intercept of 2. Now there are many methods to solve this question. Let me write those methods as method 1, method 2, and method 3. So I'll show you 3 different ways of doing it. One of them is you could begin by writing y equals to a times. Now these are the factors. That means x minus this one root, which is minus 3 plus square root 5, right, times x minus the other root, which is minus 3 minus square root 5, correct? Solve this equation and use the y-intercept to find a. That is one way of doing it, right? The other way to do this particular equation is to write equation as a times. We could write this as x squared minus sum of roots times x plus product of roots. So sum is very simple. When you sum the two roots, you get minus 6. And when you do product, we get 9 square. I mean, 3 square is 9. 9 minus 5, which is 4. So that also will give you a very quick answer for this particular situation. To find the value of a, you can use y-intercept. So this is even better than the first method. But I'll show you the third method, which is very interesting and useful. So what we do basically to quickly get the answer is that we know what are the roots of equation, right? Roots of the equation are x equals to minus b plus minus square root of b square minus 4ac over 2a. These are the roots of equation, right? Now, what are we given? Let's look into it. We are given minus 3 plus minus square root of 5 divided by 1. Now, by simple comparison, we can find quadratic equation. I hope you're getting the point, right? So, what I'm trying to say here is that if my equation is y equals to ax square plus bx plus c, then from comparison, I can get all the values. So let's look into it. How? Now that's the whole idea. So 2a equals to 1. So we have 2a equals to 1, a equals to half. So first value. How did I get it? I'm comparing these two. That standard equation and what is given to us. Minus 3 plus minus square root 5 over 1. So I use this and find the value of a. Does it make sense to you? Very important, right? Now, you can just read the value of b from this equation. Do you see that part? So what is b? So b is equal to 3. You don't even have to think about it. Do you see that part? Right? Now you know a, you know b, and you need to find what is within the square root, the radical part. Within square root, it is b square minus 4ac. Correct? So how do you find that now? Well, simple. You can do it now, right? So it is to be done like this. B square minus 4ac is equal to 5. Within radical, what do you see? Just connect these two. Inside we have just 5, right? Now we know what b is. B is 3. So write 3 square. Minus 4 times a is half. And c we want to know. Perfect. So we got 9 minus 2c equals to 5. Now just solve for c. Does it make sense? So take c to this side. So we get 9 minus 5 equals to 2c. 4 equals to 2c and c equals to 4 divided by 2, which is 2. So you get your equation. So now you know that c is equal to what? We know c is equal to 2. So we know our a, b and c. So we know the equation y equals to ax square plus bx plus c. Substitute these values, write down your answer. So the answer for the given root is y equals to half x square and b is 3. So we get plus 3x and c is 2 plus 2. Do you get it? So if you solve like this, you do not have to land into these difficult calculations and you can get exact answer in no time. Perfect? I hope you appreciate it. Now let's move on and take question number 4. Question number 4, we are given two equations, y equals to 4 minus x square and a linear equation x plus y equals to 2. Determine the points of intersection, answer in radical form. So let's rewrite the equations. We have y equals to 4 minus x square and the other one is x plus y equals to 2. Now from equation number 2, we can write y equals to 2 minus x, correct? So let me give the equation numbers. It becomes easier to explain. So we had equation number 1 and 2. From 2 we got equation number 3, which is y equals to 2 minus x. So now we'll sub equation 3 in equation 1, correct? Both are y. So we are trying to connect these two equations to find our solution, right? So if you do that, what do you get? You get 2 minus x equals to 4 minus x square. So let me write here, we get 2 minus x equals to 4 minus x square. So we get a quadratic equation, right? Bringing x square to the left side, we always want to keep this positive. This is very important to understand. So we get x square and then we already have minus x here plus 2. We'll bring 4 here, so we get 0. So the equation becomes x square minus x minus 2 equals to 0. Now to factor this, we could take product and sum. So two numbers whose product is minus 2, we want negative 1x here. So it could be x minus 2 times x plus 1, correct, equals to 0. So that gives us two values of x. One is x equals to 2, the other one is x equals to minus 1. So for these two values, we are getting intersection of those 2 points. We need to determine the points of intersection, so means we have to find the y values also. correct? It's very important to understand this part. We have two x values, x equals to 2 and x equals to minus 1. So we can use one of our equations, which is y equals to 2 minus x, to find the value of y. If x is 2, then y is equals to 2 minus 2, which is 0. So that gives you 1 point, and this point is 2, 0, correct? Now, for the second point, we'll take x as minus 1. So if I write x as equal to minus 1, then y value will be 2 minus minus 1, which is equal to 2 plus 1, which is 3, or the coordinate point is minus 1, 3. So now we can write down our answer, and the answer is that the intersection is at these 2 points, which are minus 1, 3 and 2, 0. You get the idea. So that is how we are going to solve this particular question. I hope that makes sense, right? So let's move on and take up question number 5 now. Question number 5. Find the value of k that makes x squared plus k plus 7x plus 7k plus 1 a perfect square. So we are given the equation as x squared plus k plus 7x, I should say trinomial, which is given to us. We want to make this as a perfect square. So what is the condition, right? So when we say perfect square, it really means what? Let's try to see that also. So if I have a plus b as whole square, then that should be equal to a square plus 2ab plus b square, right? Now in this condition, we could treat this as x square plus, we have here k plus 7 times x, and this number we would like to write it as a square. So think like this. We have square root of 7k plus 1 whole square, right? So that becomes the same thing, right? Now the center term, which is twice ab, a is 1 for you, right? And b is this number. That should be equal to 2 times in between number. Got it? So that is the whole idea. So that gives you the equation. So the center term is for you 2ab, which is this term, right? So twice a is 1 for us, and b is square root of 7k plus 1, right? So twice ab, so a is 1 square, we are trying to say that. B is square root of 7k plus 1. Twice ab is the coefficient of x, which is k plus 7. So that gives you the condition for a perfect square. Got it? To solve for it, let us square both sides. We are going to square both sides. Then what do we get? 2 becomes 4. So we get 4 times 7k plus 1 equals to k plus 7 whole square. So let's expand this. So we get 28k plus 4 equals to k square plus 14k plus 7 square is 49. Now bringing all the terms together, we get 0 equals to k square plus 14k minus 28k plus 49 minus 4. That is k square. Now 14 minus 28 is minus 14k, and here we get plus 45. Now this could be factored. 9 times 5, both negative. So we get 0 equals to k minus 9 times k minus 5. Correct? So we get a factored form of our equation. From here we can easily write down the values of k. So k minus 9 equals to 0 means k equals to 9, and k minus 5 equals to 9 means k equals to 5. So we have two answers, that is k equals to 9 or 5. Correct? So that is how it can be solved. Now let's take up the word problem. Now here is question number 6. A toy store owner sells a $25 toy which results in annual sales of 3,000 units. The store owner estimates that each $2 increase in selling price will decrease sales by 125 units. Also, the toy costs the store owner $17 each from the toy manufacturer. Find the selling price of the toy which will maximize the owner's profit. So let's try to understand. We want to find the selling price, right? And what is selling price equal to? It is revenue minus cost. So we need to maximize selling price. How do we get revenue? You get revenue by multiplying the dollar value to number of items sold. So revenue basically is multiplying dollar value with number of items sold, right? Now in our case, the dollar value is $45. So we could write this as $45. Since we want to increase the price in multiples of 2, that means multiples of 2, we say plus 2n, let's say, 2 multiples. But when we do that, the numbers sold will not be 3,000 but less. So it will be 3,000 less 125 for each $2 increase. So that means 125n. You get this idea. So first part of the equation, very important to understand. So those are the items sold. Now each of such item is going to cost $17. So we have to take away that cost. That is 17 times all these items. Is that clear? Most important, right? So we can say this is the sales price S. Now I'm going to show you a very good method to solve this kind of an equation. We are going to factor. We have a common factor here, the number of items sold, which is 3,000 minus 125n. So you get 45 plus 2n, and here we get 17 minus 17. Do you see that part? So once you factor, what could you do? You could find the axis of symmetry, and that will give you n value for maximum selling price. Does it make sense to you? So here we have 2n. 45 minus 17 is how much? 28, right? So we get plus 28 here. 45 minus 17. So I hope you understand the concept. This is a parabola which is kind of like this, right? And what we're looking at is we want this point, selling maximum sales, right? We can find what these two x-intercepts are. Once we find intercepts, we can then find the x's as average value of these two, right? So if this is like x1, this is x2, then the value of n is equals to x1 plus x2 divided by 2. Is that concept clear? Perfect. So that is the concept with which we are going to solve further. So when is this factor 0? This factor is 0 for n equals to 3,000 divided by 125, which is times 2 is 250, 500 means 24, right? When is this factor 0? When n equals to minus 14. 28 divided by 2. Perfect. So we got these two values. These are, let's say, n1 and n2. So the average is in between. So n equals to, for maximum value, add them up, 24 plus minus 14 divided by 2. So that is 10 divided by 2 or 5. So for n equals to 5, we get maximum profit. I should have written not selling price. I'm sorry. This is all profit. Okay. It's good I saw this. This selling price this is the profit. The selling price is this, right? Okay. So we need to find the selling price. So what is the selling price for us? Selling price is, let me highlight it since I did a mistake there. Okay. This is the selling price. So this is the selling price and that is the number sold. So the selling prices, we have to put the value of n as 5, correct? So it is equals to 45 plus 2 times 5, which is 45 plus 10 or $55, right? So our answer is $55. Perfect. So that is how we are going to find the answer for this particular question. So the profit is revenue minus cost. Revenue is selling price times number of items sold. Cost is cost of each item times number of items sold, right? And you could factor and solve easily without completing the square. So I hope you understand and appreciate this method. So let's move on and take up the 2 communication questions. So we are almost at the end. We'll do now question number 7 and 8. Question number 7. You are given a square root function and asked to find the equation of the inverse. Explain clearly the steps you would take to find the equation and how you would adjust the equation. Now this is extremely important communication question. Try to understand. First step here is to find domain and range of square root function. Right, so that is kind of very important, right? And once you find domain range of square root function, you know that domain and range of inverse will swap. So let me make you understand what I'm trying to say here. So let us say we have some square root function which is, let's say, kind of like this. Right? So in this case we are saying, for example, that the value of the function is, let's say, like this. So we are saying that x is greater than equal to a and y is greater than equal to b. Let's say this is b, right? So that is the domain and range for the function here, right? So we are saying x is greater than equal to a and y is greater than equal to b. So as far as the inverse is concerned, so inverse will be kind of what? So for the inverse, this point, which is AB, will become BA, right? So it could be, let us say, somewhere here, right? So BA, it could be somewhere here, but the value will be kind of like this. So we're taking that point will be BA. So for the inverse of the function, the domain will be greater than equal to B and the range, let me write y, will be greater than equal to A. So they swap. Do you understand? This is kind of very, very important step to begin with. Right? So they will always swap. Now that is your first thing. Look into domain range. And then these steps should be, so whenever you have a square root function, what you need to do here is swap x and y, right? So swap x and y and then solve for y as you would normally do for any inverse function. And then the last part here is adjust the equation. So you have to adjust the equation by including modified or domain and range restrictions. So do you understand? That is what is very important to figure out. For example, if I have an equation, let us say we have equation y equals to, let's say, square root of x minus 1 plus 2. Now, in this particular case, we have x which is greater than or equal to 1 and y which is greater than or equal to 2. So that is for the function. For inverse, when we do the swap, then it will be like, let's do it. It will be x equals to square root of y minus 1 plus 2. So we get x minus 2 equals to y minus 1. So when you, let me write like this. Then we have x minus 2 whole square equals to y minus 1. And after this, when you rewrite, you will write y equals to x minus 2 whole square plus 1. Now at this stage, you have to include that x is, you have to flip this, right? So you have to say x is greater than or equal to 2 and y is greater than or equal to 1. So that is what I'm trying to say when I say that your domain and range of inverse will swap. So you have to swap, and this is the restriction which has to be adjusted. So it is not just a parabola, because the parabola is going to be like this. We are not taking the left part, we are only taking the right side of the parabola by making this restriction. So this is a very important thing which you have to highlight when you communicate about the procedure of finding inverse of square root function. So I hope that is absolutely clear. Now let's take the last question, which is question number 8. It says, for a function of the form, let me rewrite the form, f of x equals to a times x minus p whole square plus q. How would one use the values of a and q, that means these two values, to find the number of zeros? Correct? So as you know, the number of zeros could be how many? We could have number of zeros as equal to none, right? So we say 0 or none, right? We could have number of zeros as equal to 1, or we could have number of zeros as equal to 2. So there are three conditions. Now how do we find from A and Q all the three conditions? For none, no zero at all, it is important that if A is less than 0, then Q is also less than 0, and if A is greater than 0, then Q is greater than 0. That means we have same sign of A and Q. So that gives you the first condition. Do you understand? Now what we are trying to say here, that if A is less than 0, that means it is opening downwards, Q is negative, right? So let me just sketch here the condition. So if I go for the first condition, the parabola will be kind of like this. A is negative, opening downwards, Q is negative. And if I have the second condition, when A is positive and Q is positive, then the parabola will be 0. They are not crossing the x-axis, therefore none. Got it? Now in the second case, when we want only one zero, in this case, Q equals to 0. Now in this case, A could be anything, but if Q equals to 0, in that case, we have a parabola which is with a vertex on the x-axis, right? So either it could be like this if A is positive, or it could be like this if A is negative, right? And the third condition being 0, two zeros, that is possible if and only if A and Q have opposite signs. Perfect. So in the first case, A and Q have same signs, and in this case they have opposite signs, right? So that basically means that if A is less than 0, then Q is greater than 0, and if A is greater than 0, then Q is less than 0. Perfect. So that will ensure 2 zeros. So that is how you could answer this question. I hope you have enjoyed and learned how to answer such a paper on quadratic functions. Feel free to write your comments and share your views. Each and every question in this was very important, and I could have actually taken them as independent questions in my set of videos. But collecting them together helps you to prepare for your own test, and I hope you will take full advantage of that. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.